Hi guys, so let's start the rate of reactions lab. So you should have your two bags, reaction 1 and reaction 2, with pipettes in both of them. In order to access the ingredients in there, we need to take the pipettes and cut them off. Hint, they're just baking soda and vinegar. So once we cut the tip of the pipette off, we can put the pipette in the bag and seal it like this. Now, in order to get the reaction to occur, we're going to push on the pipette, letting all the liquids out. And we should see a rate of a reaction start happening, a fizzing and a bubbling. We want to time how long this happens. Is it happening for a little bit of time? A lot of time? How long does it get? Does our bag have any more air in it, which it should? For this, I'm actually going to do a little bit more than you are. So I'm going to do this a little bit different, because I'm going to use a balloon to do this reaction. So, no, your bag at home will not go over, but I'm going to go a little bit more. I'm going to use a balloon. The reason that I'm using a balloon is because now I can seal this bag, pushing all the air out. And for my reaction 1, we're going to see how big we can actually get it. Now, we said concentration matters. This is not diluted, so this is a full strength concentration of acetic acid. This is the stuff this is just vinegar that you'd find in the store. And so we can time how long the bubbles go and how long it lasts. For the second rate of reaction, I'm using a dilution. And so I'm pouring the same amount into a balloon. Actually, I poured a little bit more of the dilution. This one is a diluted vinegar. Again, pushing all of it down. We're going to see the rate of this reaction. Now, I put quite a bit more in there than I did in the first one. And we can see this rose a lot more. So what if I did a bigger quantity? So if I use more reactant, even though it's less molarity, it worked really well to create a larger reactant. But what if I use more of the stronger reactant like I did the second time? Well, let's see what happens. So remember, this one was a less concentrated, but I used a lot more of it. I'm going to repeat the first reaction using the same volume that I did for the second one, but it's of a stronger concentration. And then let's see what happens to the bag. So again, I'm putting the vinegar in balloons so I can remove all the air and see that same reaction occur. So this one is a stronger reactant. Whoa. And we can see, now that they're the same concentration, this bag is a lot fuller than this bag. Oh, I just popped my bag. So it actually just popped open. I'm letting you guys use pipettes at home so you don't do this. That one is a full, solid bag. This one still has a little give to it. We can see thickness-wise, one of them's much fuller. So if we have a stronger concentration, that will increase the rate of the reaction than a weaker concentration. But if you have more volume of the reactant, like we did this time, you'll have a bigger reaction. But when you use the same volume, the stronger concentration will always cause more of a reaction. Also, when you start looking at this, we can still see there's baking soda. If I feel it, there's still baking soda in this one. You can see the white kind of on the edges sometimes. Where this one, it's reacted quite a bit of the baking soda out. And it's still bubbling. Still fizzing. And you can hear it. Broke open. My seal is broke. So that's the rate of the reaction.